Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 4 Notes 4 on factoring special cases. So special case factoring, I can factor special cases is what we're looking at today. So we've been talking about factoring for at least a week now, and today we're going to be looking at some cases that look a little different than the standard trinomials that we see most often, and talk about what do we do with that. The first one that we're going to look at is called a difference of two squares. If you are subtracting two perfect squares, so in other words, your b term is 0, and remember that comes from that standard form of a trinomial. Standard form of a trinomial is ax squared plus bx plus c. So if your b term is 0 and it's gone, and you're subtracting these two, if they're perfect squares, then the factored form ends up being the same two factors, but one is adding and one is subtracting. Okay, so difference of two squares. Sometimes you'll hear this referred to as the sum and difference pattern. So let's just talk about steps that we would go through to factor the difference of two squares. The first one, we always want to check for GCF, but in this case, we only want to take out the GCF if it makes perfect squares. If there's a GCF that's in there and you already have perfect squares, just leave it in there, because if they're perfect squares, then you can factor them very easily. But if when you take the GCF out, it makes a perfect square, then that's when you want to get rid of it. Then you'll have the difference of two squares left over. Set up your factored form. You've got one that's going to be adding, one that's going to be subtracting. And you can leave spaces to write in your factors. And we're going to take the square root of each term in the original question. So once we take the square root of each term in the original question, the square root of the first term goes in the first spot, and the square root of the second term goes in the second spot in each set of parentheses. Okay, so take the square root, you've got first term in each parenthesis, second term in each parenthesis. Let's just take a look at what this looks like. For number 1, we have n squared minus 25. Now, n squared is a perfect square because it's n times n. And 25 is a perfect square because it's 5 times 5. And we're subtracting. So I know I have a difference of two squares pattern. So I know my factored form is going to be the same two parentheses that I always have. One's going to be adding, one's going to be subtracting. And when I take the square root of each term, square root of n squared is n. The square root of 25 is 5. So I have n plus 5, n minus 5. That's my factored form. So you end up getting the same two factors, n and 5, but in one parenthesis you're adding and in one parenthesis you're subtracting. Let's take a look at number 2. 36 is a perfect square, x squared is a perfect square, 49 is a perfect square, y squared is a perfect square. They're all perfect squares, and I'm subtracting in the middle. So again, I have a difference of two squares pattern, no GCF to take out. I'm going to have my factored form, one's adding, one's subtracting. Take the square root of the 36x squared. Square root of 36 is 6, square root of x squared is x. Take the square root of 49, y squared. Square root of 49 is 7, and the square root of y squared is just y. So then when I plug those in, I have 6x plus 3y, or 7y, sorry, 7 there, and 6x minus 7y. So there's my factored form. Same two terms, one is adding, one is subtracting. Let's look at a couple more. In number 3, I have 48a to the third minus 12a there. So now I don't have perfect squares as they are, but I have a GCF that I can take out. I can divide that by 12 and a. If I divide by 12a and take the GCF out front, I have 4a squared minus 1 left over. 4a squared is a perfect square and 1 is a perfect square. So now that's a GCF that's just going to be out front of my factored form like it was when we had trinomials. Then I take the square root of the two things inside. Square root of 4 is 2. Square root of a squared is a. Square root of 1 is 1. So I have 2a plus 1 and 2a minus 1. That's my factored form, and again, that GCF is still out front. Let's do one more question together. In number 4, I have 9x to the third minus 4x. Again, I don't have perfect squares yet because x to the third and x are not perfect squares, but I can take a factor of x out. So I'll have x out front, leaving me with 9x squared minus 4, and those are perfect squares. So now take the square root of this, take the square root of that. I have that x out front. This one's adding, this one's subtracting, and it doesn't matter what order. You could put the subtracting first and the adding second. It'll give you the same thing. So 3x and 2, 3x and 2. And that is my factored form. So it's pretty quick if you recognize the pattern. If you don't recognize the pattern, you can always go back to the factoring that we're used to. If, for example, let's look at number 4. If I look at number 4 and I don't recognize that those are two perfect squares, take the x out, which gives you x and then 9x squared minus 4. And you're missing that b term that's in the middle, so just put it back in. 9x squared plus 0x minus 4. And then you can set up your factor x and go from there. 9 times negative 4 is negative 36. The middle term would be 0. You'd get negative 6 and 6. And then I'd split the middle. 9x squared minus 6x plus 6x minus 4. Group them, and keep going. From the first group, I can take out a 3 and an x. So I have 3x out front. That leaves me with 3x minus 2. Then I can take out a 2 there, leaving me with 3x minus 2. So if you'll notice, I get 3x plus 2, 3x minus 2 with that same GCF that I had in front. The factored form ends up being the same. It's just nice if you recognize the pattern because it just is easier and it speeds up your process a little bit. If you don't want to use the pattern, that's fine. Just fill in your middle term with 0x. But the pattern makes things a little bit quicker and a little bit easier. All right, we're going to stop our video there for today. Thanks for listening. Don't forget to hop back to Schoology and take that quiz, and I will see you all tomorrow.